So they used to take us very well. Hi everyone, welcome back to Made Easy Academia. Please don't forget to like our videos, share so that others can be able to benefit. So and subscribe. If you subscribe, you'll be able to have an access to our material we are using. There's more exercises. So we are still under physical chemistry. The one we're going to talk about today is chemical bonding, and most especially ionic bond and covalent bond. But firstly, the thing is, we have to know the oxidation numbers of elements. Okay, I will even teach you how to, fine. So this is Medicine Academy. I even tell you how to name a compounds, how to find their, what do they call it? How to find their oxidation numbers. I'll break it down so that you'll be able to understand the concept of this area. Now, for this case, I'll firstly group the element. How can we determine the oxidation number of elements? Most people don't know this. So I'll talk about that. Or what I will do is I will talk about bonding here, then naming of compounds. We're going to do that one separately, then we go further. Now, for chemical bonding, let's first talk about how to okay, let me change the heading. Chemical bonding and naming of compound. Naming of compound as well. Let me add it. Naming of compound. Chemical bonding and naming of compound. So in bonding, you need to firstly know how to identify the oxidation numbers of elements. Is the element, is it a metal? Is it a non-metal? Is it a metalloid or is it noble gas? So for the element is divided into four. Element is divided into four. The most important, we have metallic element, we have non-metallic element, we have noble gas, and we have metalloid. So those are the cases that we have. We have metallic element, we have non-metallic element, we have noble gas, and we have metalloid. So when we have metallic, don't worry, I will define that one in the materials. Metallic element is a type of element that gives electrons. This one, they give electrons. That gives electrons. They give electrons. So when they give electrons, they become positive. So whenever you have in any way, when the element is positive, you will know that that particular element is a metallic element. But if it is negative, that one is a non-metallic element. Non-metallic element. So the other one is what we call, so the non-metallic element are those elements that is gain electrons. Let me just write it that way. Non-metallic elements are those elements that gains electrons. This one will gain, you know. This one is losing, gives electron. This one is gaining electrons. So when they gain electron, they are not the owner. You know, they are not the owner, they just borrow them. That one is it will become negative. For example, if I have an element like this, let's say I have oxygen. You know, oxygen is you can see that indicating that this is a non-metal. They give him two. For noble gas are those elements that have already balanced or completed their octet structure. That one they are already complete, meaning they don't need and they cannot give out. But for the metalloid, this one they have already completed their octet structure. But for brother metalloid, they cannot give at the same time, they cannot receive. They are not complete. It's different from noble gas. Noble gas, they are already complete and they cannot give out. But for metalloid, they are not complete yet. At the same time, they cannot see any element to receive. But you know, sign can also take a U-turn. You understand? You know, we have two types of shell. We have using XPDF. At the same time, we have using KLMN shell. I'll be using that one. But please, don't be confused about this. You know, we have law. Okay, let me just put it down. So before I go further, let me tell you this. You know, I told you when the elements have a positive, they call metals. When they have negative, we call them non-metal. So you have to know this one, please. For this case, for first 20 element, know this at the back of your mind. For metallic element, we said they will become positive. So In chemistry, element can give 1, they can give 2, at the same time, they can give 3. Since they are meta, they are giving out. If they give out 1, that is plus 1. If they give out 2, that is plus 2. If they give out 3, that is plus 3. Then the other one we have is a non-meta. For the non-meta, we say if they receive, they become negative. Element can receive 1, they can receive 2, at the same time, they can receive 3, which means the maximum is 3. They can give 1 for the first 20 element. They can give 1, they can give 2, they can give 3. Then for the non-meta, they can receive 1, they can receive 2, they can receive 3. All those elements that can give us electrons are called positive. All those ones that need electron, that receive electron, they call them non-meta. So you'll be wondering, so how are we going to determine that? We'll be using electronic configuration, using KLMN shell. Electronic configurations, let's talk about that for the first 20. So don't forget, I told you science too can take a U-turn. So, but we don't need to stress ourselves in lying that one. Just note that one in the back of your mind. Electronic configuration. We have different type of shell. We have K shell, we have L shell, we have M shell, we have N shell, even we have O, P, Q, R, X, T, U, V, W. There we have those kind of shell. So since we are dealing with first 20 element, I'll be making use of K, L, M, N shell. Please don't confuse about this. Science too can take a U-turn. We have a law that we are going to be using 2n squared. The first one, if n is 1, 2 times 1 squared, that is going to be 2. Meaning the maximum set for this is 2. If n is 2, 2 squared is 4, 4 times 2 is 8. If n is 3, 3 times 3 is supposed to be 9, right? And 9 times 2 is supposed to be 18. But we are taking a U-turn now. So this is 8, this is 18. So meaning the maximum for this is 2. To write this electron configuration for this case, it's supposed to be 2, 8, 18, then 32, right? But for the first element, this is how we are going. It has a law, but in order not to waste our time, just have this at the back of your mind. So for the K shell, we have 2. For the L shell, we have 8. For the M shell, 2, we have 8. For the N shell, we have 18. So let's see how we are going to write for the first element: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Okay, let me label them first. 8, 9, 10, 11. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. K, L, M, N. So the first element we know is hydrogen. This is helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So let's write the electron configuration of this element after the other. Hydrogen is 1. Since hydrogen is 1, it's going to be under K cell because K cell can occupy 2, right? So we have 1 here. Are you following? Yeah. Helium is 2. It's going to be here because this one can occupy 2. But look at lithium. Lithium is 3. Can we put 3 here? No, of course, because if you put 3 here, let me identify this. The moment I put 3 here, I've already violated the law for this one because this one cannot contain more than 2. And this one is 3. I can just have 2, 1. You can see 2 plus 1, and we have 3. So beryllium is 4. That's going to be 2, 2. Boron is 5. That's going to be 2, 2, 1. No, because this one can occupy up to 8. Those are 2, 3. Carbon is 6. That's going to be 2, 4. Nitrogen is 7. That's going to be 2, 5. Oxygen is 8. That's going to be 2, 6. Fluorine is 9. That's going to be 2, 7. Neon is 10. That's going to be 2, 8. Can you see? You can see that it's simple and straightforward, right? Now look at this one. Sodium is 11. Can I write 2, 9? No, because this one cannot occupy more than 8, so we just have 2, 8, and 1. So now, if I look at the next one, magnesium is 12. That's going to be 2. This one is 2, 8, 8, 18. That's that. Don't be confused, please. If you are using that 2n square, it's supposed to be 2, 8, 18, 32. So science can take a U-turn. This is how we normally use it. So this one is at 2, 8, 2. Aluminum is 13. That's going to be 2, 8, 3. Because M72 can occupy up to 8. This is silicon. That's going to be 2, 8, 4. This one is at 2, 8, 5. This is 16. That's going to be 2, 8, 6. This is 17. 2, 8, 7. This one too, we have 2, 8, 8. Then you can see this one, we cannot write 2 now because this one has already occupied now. I can have 2, 8, 8, 1. For this, I can have 2, 8, 8, 2. Can you see that? You'll be wondering, why do we need all this? You see the beauty of chemistry now. Now, I want to use all this one to determine my oxidation number. Recall, I told you, elements, if it is metal, for the metallic element, they can give 1, they can give 2, at the same time, they can give 3. And for the non-metal, they can receive 1, they can receive 2, at the same time, they can receive 3. So, let's take a look at, let's take one example. Take any one of your choice. Okay, let me close my eyes and pick one. Maybe I pick oxygen, for example. What do you have, oxygen? Oxygen is number 8, right? That is 2 and 6. Can you see that from here? Is it number 8? This is K shell. Then we have L shell. K is 2. At the same time, L must be 8. So it balanced the first cell. Can you see? It balanced the first cell. But the second cell, is it balanced? Is it balanced? Yeah, it's not balanced. So how many electrons do we need to complete it to balance? Yeah, 2. So since it will receive that 2, it's not the owner, then oxygen is going to be -2. So oxygen is a non-metal. Can you see that? But we need 2 to balance. Let's close our eyes and pick another one. Which one do we need again? Let's determine for chlorine, for example. Chlorine is number 17. It's a 287. So it has 3 shell, K shell, L shell, M cell. So this must be 288. So you can see it balanced the first cell. It balanced the second cell, but third cell, is it balanced? It remains what to balance? 1. So chlorine is going to be -1. Can you see that? You can see that it's very simple and straightforward. Let's see for another one. Let's see for, let's take a look at, maybe we take sodium, for example. Sodium. Let's see sodium. Sodium is number 11. That's 281. That's 3 shell, K shell, L shell, and M cell. So K must be 2, L must be 8, and M2 must be 8 as well. So it balanced the first cell. Can you see? Balance the first cell, balance the second cell. But the third cell, is it balanced? It is what to balance? 7. Can they see 7 electrons? Recall we said they can only receive 1, 2, 3. They can only give out 1, 2, or 3. So it cannot see 7 electrons. It can give out the 1 it has. So if it give out the 1 it has, so which means sodium is +1. So that's the metal as well. You understand? Let's take a look at case of neon. You see, neon is number 10. Neon, that one is 2, 8. So this is K shell, L shell. K must be 2, L must be 8. Balance the first cell and also balance the second cell. So this one is balanced without anything. Then this one is a noble gas. That's why I said those elements that have already completed their own octet structure is what we call noble gas. So in any case, if you want to determine the oxidation number of any element here, you can pick any of your choice. Use the same logic, the same tactics to determine that. Then now go to the main thing, which is bonding. The reason I firstly go here is how can we determine, because I'll be using the oxidation number there. You understand? Like if I said, what is for the calcium? That is +2, 282. So for potassium, I'll be using that one. So it's good for you. Even when you are naming compounds, these two is also important. So let's see. So let's talk about the two bond that we are going to talk about here. We have what we call a covalent bond. So we need to refill the marker. We have what we call a covalent bond. So this electrocovalent bond, they call it ionic bond. It's still the same thing. Either they use ionic bond or they call it a electrocovalent bond. It's still the same. So then the other one, we call it a covalent bond. So covalent bond. So when we are talking about ionic bond, it's a type of bond that deal with transfer of electrons from metallic element to non-metallic element. That is, under that case, one has to be metallic element and the other one has to be non-metallic element. What are we trying to say? In any case, it's under the electrocovalent bond, just like these expressions. One must be metal, the one that will give out electrons, and the other one has to be non-metal. So when we have these situations, that one is what we call electrocovalent bonding. But the other one is just pairing and sharing. So the two of them has to be non-metal. If they are non-metal, they will just pair and share the electrons. So how are we going to do that? Let's say, for example, let's take a look at this example 1. They said, consider the following element. Consider the following element with electronic configuration. Electronic configuration. We have element X, we have element Y. This is element. Electronic configuration. Let's say here we have 2, 7, and here we have 2, 8, 2. So now the question now said, the first question said, identify X and Y. 2, let me write them here so that to save our time. 2, what types of bond? What types of bonds that can exist between X and Y? 3, show the chemical formula. Show the chemical formula between X and Y. Then 4, we say give 3 properties. We say give 3 properties. Give 3 properties of the types of the types of bond formed. So let's see how we're going to deal with this. Just a simple and straightforward. So this is the element. We have element here. And we have here, let me write it in full. We have electronic configuration. So how are we going to do that? How are we going to go with that? So the first thing to be considered, the first question they said we should identify element X and Y. So now let's see for the element X. The first questions, element X, we want to determine which element is X. So now, you see, for X, we have 2, 7. So 2 plus 7, that's going to be 9. So which element do we have in number 9? It's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. You can see the one we have in number 9 is what? Yeah, of course, it's the nice fluorine. So that means X is fluorine. X is fluorine. And what about Y? Y, which element do we have? Let's check. This is 2 plus 8. We have 10. 10 plus 2, we are going to have 12. Which element do we have in number 12? It's magnesium, right? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. So Y is magnesium. So now, that's the first question. So the second one is said, what type of bond exists between them? between X and Y. You know, I told you if it is a electrovalent bond, one has to be metal, one has to be non-metal, so that one can give, because the ionic bond is a type of bond that deal with transfer of electron from metal to non-metal. But if it is in the case of what do we call it? The case of the other one is just pairing and sharing of what? Pairing and sharing of electrons. So let's see if that one will work. Let's see how it's going to go with that question. Second question. So now the first thing we are going to do, let's write out the oxidation number of X and for Y. So X is 27. That's a K shell, L shell. So this must be 2 and this must be 8. So it balance the first one, can you see? But the second one is not balanced. It didn't want to balance. It didn't want to balance. So that means I can say X is -1. Then let's check for the second one. Let's check for the second one. Y is 282. This is a K shell, L shell, M cell. This 288. So it balanced the first cell. Can you see? It balanced the first cell. Also balance the second cell, but third cell is not balanced. It remains 6 to balance. So since the maximum they can see is 3, it cannot give out. They cannot see 6 to receive. Then it can give out the 2. So that means Y is going to be +2. So Y is +2. You can see that. So X is non-metal and Y is metal. So I told you, if one is metal and one is non-metal, what type of bond will exist between them? Yes, of course, it's going to be ionic bonding. So now let's see the other one. The second question is the third one. It says show the chemical formula between X and Y. So if I want to do that, X is -1 and Y is +2. So if I react that one together, I can have X2 then Y1. Can you see that? Because why is it Y come first before X? Because Y is the metal and X is the non-metal. So the metal must come before the non-metal. You'll be saying why is it not -1? You only take the numbers, you don't need to take the negative. As Y1, X2. Oh, sorry about this. This is supposed to be Y1, you see? Metal will come, that's what I was firstly explained. Metal will come before the non-metal as Y1, then X2. And this is the same thing as a YX2. So in any cases, the metal must come before the non-metal. Please don't forget that the metal must come before the non-metal. So that's why we have YX2 there. So the fourth one is to give 3 properties of the type of bond form. I know you do know you have many properties for ionic bond. I said you can have what do we call it? You have high melting point, high boiling point. They are solid at room temperature. At the same time, they have just like the opposite of that one. They are good conductor of electricity. So if it is covalent, that means they are bad conductor of what? They are bad conductor of electricity. So let's see another examples. Let's have one more examples. Let's have one more examples. Like this one. They said, consider the table below. Consider the table below. Element, electronic configuration. We have A, B, C, D, and E. So here we have 281. Here we have 288. Here we have 26. And here we have 27. And here we have 2881. They said, first question says, identify A, B, C, D, and E. 2, show the chemical formula. Show the chemical formula between A and C. The third one, write or what types of bonds, which of the elements cannot participate in a chemical reaction. Which of the elements cannot participate in a chemical reactions? The fourth one, maybe they said, what types of bonds exist between maybe let's say A and C. So now let's look at this. Okay, let's look at this one. We are given this table. We have the element here and we have their electronic configurations. So we have A, B, C, D, E, and element A is 281, B is 288, C is 26, D is 27. At the same time, E is 2881. The first question they said, identify element A, B, D, and E. So A is, A is 2 plus 8, that's going to be 10. 10 plus 1, that's going to be 11. Which element do we have in number 11? Yeah, that is sodium. So that means A is sodium. What of B? Can you check B? B is which element? Which element do we have in number 18? That's argon. Then C, 2 plus 6, that's going to be 8. Which element do we have in number 8? Yeah, oxygen. That is C is oxygen. What of D? 2 plus 7, that is 9. Which element do we have in number 9? Yeah, that is fluorine. So D is fluorine. Then E, 2 plus 8, that is going to be 10. 10 plus 8, that's going to be 18. 18 plus 1, we are going to have 19. Which element do we have in number 19? That's potassium. So that means E is potassium. So now, the second question, they said, we should show the chemical formula between A and C. Between A and C. Okay, A, look at A. A is 281. This is K shell, L shell, M shell. This is 2. This must be 8. This must be 8. The balanced Vox one, can you see? Balance the second one 12. So, but the third one is not balanced. It remains 7 to balance. It cannot see 7 electrons, but it can give out the one it has. So if it gives out the one it has, that means A is going to be plus 1. So here we are going to have A to be plus 1. Then let's look at second one dimension C. C is 2, 6. It needs 2 electrons, right? So how do we do that? 2, 6. This must be 2. This is K shell, L shell. This must be 2. This must be 8. Balance the Fox one, but second one is not balanced. It remains 2 to balance. So that means C is minus 2. So now, if they react together, I told you earlier, the metal must come before the non-metal. The one that is giving out must come before the one that is receiving. So A is giving out here. A is giving out 1. This is like this. Sometimes we have A2C1. You don't need to put the negative. You don't need to put the negative. This is nothing but A2C. Do you get that? Now, fine. Now, the third one, they said, what is the third one? Third case, they said, which of the elements cannot participate? The element that cannot participate is the one that is what? That is already completed octet structure. That is noble gas. If you look at this, it can give out 1, but look at B. B cannot give out any electron because it's already complete. If you look at C, C2 can receive 2. If you look at D, D remain 1 to balance. If you look at E, E2 can give out. So of course, the B is the one that cannot participate. So why is it the B? Because B has already completed its own octet structure. Then 4, they said what type of bond is it between them? You see, if one is metal and one is non-metal, the only bond that can exist between them is what we call ionic bond. And I told you, ionic bond is nothing but what? It's nothing but electrophilic bond. So if you deal with pairing and sharing of electrons, we make use of covalent. But if you're dealing with transfer of electron from metal to non-metal, we make use of what? We make use of electrophilic bond. So thanks for watching. So please don't forget to like our videos, share, subscribe, so that others too can be able to benefit from this tutorial. Thanks for watching.